Section 300.3b of the National Electrical Code, or NEC, addresses the permitted arrangements of conductors. This section specifically allows conductors of the same circuit, including grounding and bonding conductors, to occupy the same raceway, cable, box, or enclosure. It's crucial to understand the definition of a circuit within the context of the NEC to properly apply this rule. The NEC defines a circuit as a conductor or system of conductors through which an electric current is intended to flow. Now, focusing on the specific scenario involving multiple circuits of the same voltage originating from the same source and housed within the same electrical box, the critical question is whether the grounded conductors, also known as neutrals, can be joined together. The answer, according to the NEC and standard electrical practice, is yes, provided all the circuits originate from the same electrical source. This allowance stems directly from the principle outlined in 300.3b, which permits the grouping of conductors belonging to the same circuit within a common enclosure. Consider a typical residential or commercial electrical panel. It serves as the originating source for numerous branch circuits, each supplying power to different loads such as lighting, receptacles, and appliances. Each of these branch circuits has its own hot or ungrounded conductor, a neutral or grounded conductor, and often a grounding or equipment grounding conductor. The neutrals from these various branch circuits, while serving distinct loads, ultimately return to the same neutral busbar within the electrical panel. This neutral busbar is then connected to the main grounding electrode conductor, which establishes the connection to the earth. Therefore, within the context of an electrical box, joining the neutrals from different circuits originating from the same source mirrors the established practice within the main electrical panel. Several key considerations support this practice. Firstly, safety is paramount. Properly joining the neutrals ensures a low impedance path for fault current to return to the source, facilitating the rapid operation of overcurrent protective devices such as circuit breakers or fuses. This swift response minimizes the duration of the fault, reducing the risk of electrical shock and fire hazards. Secondly, the NEC permits this practice, as highlighted in 300.3b, reinforcing its acceptance as a standard and safe wiring method. Thirdly, practical considerations also play a role. In many electrical installations, space within junction boxes is limited. Joining neutrals can reduce conductor congestion, making wiring easier and ensuring proper closure of the box, which is essential for maintaining electrical safety. Now let's delve into some specific examples to illustrate the application of this principle. Imagine a scenario where two separate 120-volt circuits, each powering different lighting fixtures in the same room, enter a common junction box. According to the NEC and established electrical practices, the neutral conductors from both of these circuits can be joined together within the junction box, provided both circuits originate from the same electrical panel. This is because both neutrals ultimately return to the same neutral bus bar in the panel. Another scenario involves multiple receptacle outlets in a commercial building, each supplied by a separate 20 amps branch circuit originating from the same panel. If these receptacle outlets are wired in a daisy chain fashion, with the conductors passing through multiple junction boxes, the neutral conductors from each circuit can be joined together within each junction box. Again, this is permissible because all the circuits originate from the same source. Now, let's address some potential concerns or misconceptions regarding this practice. One common concern is the possibility of creating a parallel neutral path, which could lead to circulating currents and potentially overheat the neutral conductors. However, this concern is largely unfounded when dealing with circuits originating from the same source. The impedance of the neutral conductors is typically low enough that circulating currents are negligible. Furthermore, the NEC requires that neutral conductors be sized adequately to carry the maximum unbalanced load, further mitigating the risk of overheating. Another concern is the potential for creating a shock hazard if a neutral conductor is disconnected while the circuit is energized. However, this risk is present regardless of whether the neutrals are joined together or kept separate. Proper lockout-tagout procedures should always be followed when working on electrical circuits to prevent accidental energization. It's important to emphasize that this practice applies only to circuits originating from the same electrical source. If circuits originate from different sources, such as different electrical panels or different transformers, the neutrals must be kept separate. Joining neutrals from different sources can create dangerous circulating currents and potentially damage equipment. To further clarify, let's consider the differences between grounded conductors, equipment grounding conductors, and bonding conductors, as these terms are often used interchangeably but have distinct functions in an electrical system. Grounded conductors, or neutrals, are intentionally grounded conductors that carry current back to the source under normal operating conditions. They are typically identified by white or gray insulation. Equipment grounding conductors, where EGs are not intended to carry current under normal operating conditions. Their primary purpose is to provide a low impedance path for fault current to return to the source, facilitating the operation of overcurrent protective devices. They are typically identified by a green or bare conductor. Bonding conductors are used to connect various metallic parts of an electrical system together to create a continuous low impedance path. This helps to minimize voltage differences between different parts of the system and reduce the risk of electrical shock. While the original question mentioned section 250.148, it's important to note that this section pertains to the continuity and connection of grounding conductors in specific situations, such as when a receptacle is replaced. The relevant section for the general practice of joining neutrals is 300.3b, as previously discussed. In summary, the NEC permits the joining of neutral conductors from different circuits within the same electrical box, provided all the circuits originate from the same electrical source. This practice is safe, code compliant, and often necessary for practical reasons. It's crucial to understand the underlying principles and potential concerns to ensure that electrical installations are performed correctly and safely. Remember to always consult the latest edition of the NEC and local electrical codes for specific requirements and to seek guidance from a qualified electrician when necessary. Finally, consider a real-world example. In a commercial office building, several workstations are powered by individual 20-amp circuits. Each workstation has multiple receptacles for computers, monitors, and other electronic equipment. The neutrals from these circuits can be joined together in the junction boxes located under the desks, as long as all the circuits originate from the same electrical panel. This simplifies wiring and reduces conductor congestion. Let's also think about a residential kitchen. Multiple small appliance branch circuits required by the NEC for countertop receptacles originate from the same panel. The neutrals from these circuits can be joined together in the junction boxes behind the receptacles. Remember, the key is that all circuits share the same originating source, typically a main electrical panel or a separately derived system like a transformer. When working with electrical systems, always prioritize safety. To energize circuits before working on them, use appropriate personal protective equipment, and double-check all connections to ensure they are secure. A firm understanding of the NEC and local electrical codes is essential for safe and code-compliant electrical installations. It is also imperative to note that local amendments or regulations may exist which supersede or augment the NEC. Always check with local authorities having jurisdiction before undertaking any electrical work. For example, some municipalities may have stricter rules regarding the separation of neutrals in certain types of occupancies or specific applications. Also, never assume that simply because something is permitted by the NEC that it is necessarily the best or most appropriate practice for a particular situation. Engineering judgment and experience should always be used to determine the safest or most reliable wiring method. It's also good practice to label or identify circuits clearly, particularly in situations where multiple circuits are present in the same box. This can help prevent confusion during future maintenance or troubleshooting. Clear labeling can also assist in tracing circuits back to their originating source, ensuring that any modifications or additions are made correctly. Furthermore, the increasing use of electronic equipment in modern buildings has led to concerns about harmonic currents in neutral conductors. Harmonic currents are non-sinusoidal currents that can cause overheating and other problems in electrical systems. In some cases, it may be necessary to increase the size of the neutral conductor or use a dedicated neutral conductor for circuits serving electronic equipment to mitigate the effects of harmonic currents. While the NEC permits the joining of neutrals in many situations, it's important to be aware of these potential issues and to take appropriate measures to address them. Also, consider the impact of voltage drop on circuit performance. Voltage drop is the reduction in voltage that occurs along a conductor due to its impedance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. When joining neutrals, it's important to ensure that the conductors are sized adequately to minimize voltage drop, especially in long circuits or circuits with heavy loads. The NEC provides guidelines for calculating voltage drop and selecting appropriate conductor sizes. In conclusion, while the practice of joining neutrals from different circuits originating from the same source is generally permitted by the NEC, it's crucial to consider all relevant factors and to exercise sound engineering judgment. Safety should always be the top priority, and any electrical work should be performed by qualified individuals who are knowledgeable about the NEC and local electrical codes. Finally, the principle of joining neutrals only applies when the circuits originate from the same electrical source. This is a critical distinction that should never be overlooked. Connecting neutrals from different sources can create hazardous conditions and should be strictly avoided.